Bigger embeddings can make your RAG system worse, not better.
That sounds wrong, but it happens all the time. Teams pick the highest dimension they can get, then wonder why retrieval gets expensive, slow, and oddly less useful.
So this is not a nerdy model setting debate. This is a product decision with a bill attached.
Exactly. Embedding dimension is just how many numbers you use to represent a chunk of text. A 384-dimensional embedding has 384 values. A 1536-dimensional one has 1536. More slots, more detail, but also more baggage.
And in RAG, baggage shows up everywhere. Storage, RAM, index size, network transfer, search time.
Right. Imagine 1 million chunks. If each vector is 4 times wider, your raw vector memory is about 4 times larger before you even count the index overhead. That changes what fits in memory and what spills onto slower systems.
Give me a real scene, not a whiteboard scene.
Say you are building support search for a SaaS product. You chunk docs, tickets, and internal runbooks. At 384 dimensions, your vector store might fit comfortably on one machine class. At 1536, you may need more RAM, a larger index, and suddenly every replica costs more.
So the winner is not the smartest team. It is the team that can afford to be wasteful.
Or the team that measured first, because memory cost is only half the story. Search cost usually rises too. Wider vectors mean more numbers to compare during retrieval, so approximate nearest neighbor search still has more work moving through the pipeline.
And that lands directly on latency, which means users feel it.
Yes, if your chatbot needs fast top K retrieval before generation starts, a wider embedding can add enough delay to push responses from snappy to annoying. Not always catastrophic, but enough to change perceived quality.
Here is the trap then. People hear higher dimension and think richer meaning, therefore better search.
That is the trap. Higher dimension is not automatically better, because retrieval quality depends on the whole system. The embedding model, the chunking strategy, the domain, the query style, and even how noisy your corpus is, all matter.
So a bigger vector can carry more signal, but it can also carry more irrelevant detail.
Exactly. If your corpus is repetitive or your chunks are messy, extra dimensions may preserve distinctions you do not need. Then, retrieval becomes more sensitive to accidental wording differences instead of the intent that matters.
Give me another concrete case.
Think about an internal company wiki. A user asks, "How do I rotate an API key?" If you use a compact embedding model tuned for semantic retrieval, it may pull the right security doc, the admin guide, and the incident checklist. A larger embedding is not guaranteed to beat that. It might separate near duplicates more sharply, but if your chunking is bad, you still retrieve fragments with the wrong context.
So, teams can spend more and still lose because they improved the wrong layer.
Yes, and there is another strategic consequence. Higher dimension reduces your room to scale. If you plan to go from 1 million chunks to 50 million, every dimension choice compounds. Today it is manageable. 6 months later, it is the reason your infra budget and latency target are fighting each other.
That is the power shift. Early on, model choice feels cheap. Later, it locks the architecture.
Well said. And once you have built indexes, tuned caches, and replicated stores around a larger footprint, switching dimensions is not just changing one config. It can mean re-embedding everything and rebuilding the retrieval layer.
So, how should a programmer actually choose?
Start from the task, not the spec sheet. Ask what your users search for, how varied the corpus is, how much latency you can spend, and how big the collection will get. Then, compare a smaller and larger embedding option on your own retrieval set, not on generic leaderboards.
What should they measure besides accuracy?
Measure retrieval relevance on real queries, but also vector storage, index build time, query latency, RAM pressure, and the cost of replicas. If a larger dimension gives you a tiny relevance bump, but blows up memory and response time, that is not a win. That is a tax.
One more example, maybe the cleanest practical takeaway.
Sure. Suppose you are building RAG for legal contract search. Queries are subtle, wording matters. and the cost of missing the right clause is high. There, a higher dimensional model might be worth testing, because nuance matters. But for e-commerce FAQs or standard support docs, a smaller embedding can often deliver excellent retrieval at a fraction of the cost.
So, embedding dimension is really a trade-off knob, not a prestige number.
Exactly. It controls representational capacity, but it also controls operational drag. The best dimension is the smallest one that gives you the retrieval quality your application actually needs.
Which means the mature move is not maxing out dimensions. It is refusing to pay for dimensions you cannot turn into user value.
Yes, in RAG, the smartest vector is not the biggest one, it is the one that earns its keep.